Hey everybody, this is Larry. This is day 7 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, or let me know what you think about this problem on the comments or Discord or whatever. Okay, so today's problem is reverse linked list. So another, I don't even want to say standard, but it's just like a problem that people like giving, I think, for interviews and stuff. But I don't feel like I haven't seen these level of problems in a long time, but I could be wrong. It's been a while. I don't know. Let me know what you think. But yeah, okay, let's see. Okay, so basically, yeah, I mean, I think this is just kind of one of those problems where you struggle with off by one, so just wrong answers. Definitely draw it out every step of the way. The key thing to know about linked list problems in general, especially if you're trying to keep it within a pass or two, is to kind of to make sure you understand the invariants inside your loops, right? Meaning that at the end of every iteration or whatever. Man, I am sweating. I don't know if you could see it. It is 100 degrees Fahrenheit in New York, and I am literally sweating. This isn't like, I don't know, I'm really shiny maybe. But in any case, yeah, so at the end of every iteration, you have some state invariant that is still true going forward, right? Like, maybe your assumptions that are going inside, entering the iteration, is still true out after that iteration. So once you kind of have that, and that's called the loop invariant, and that's one of the key things of solving linked list problems, and also one of these things that at least I was going to say that interviewers look for, but I don't know that interviewers in general look that far ahead, to be honest. Or like I feel like a lot of interviewers don't know what they look for. They just kind of like, especially for these kind of problems where they just, try to see you solve it and that's it. They don't really try to think about what your understanding of the problem is, right? Anyway, yeah, so let's kind of get started. Left is equal to right, or less than equal to right, reverse the linked list. Okay, yeah, I mean, this is, I mean, I think, and I imagine reverse linked list one is just reverse the entire linked list. Reverse linked list 2 is, well, going to be very similar. So let's get started. And after I said all that stuff about off by one and errors, I'm very confident that I am going to make a mistake somewhere. Right? Man, I need some water. It's so hot. Ooh, that is refreshing. Okay. So one thing that I like to do in general is always to kind of manipulate current.next, just in general. So yeah, so this is how I set up my thing, and then you never manipulate current because then you have a sense. You always have a pointer to the node that you're working on, or the linked list node that you're working on. Yeah. All right. So what are we trying to do here, right? So I guess at the very least we have to do iterations. Yeah, maybe we can just do some. I mean, maybe that's fine. Maybe here we just do. Left is. Maybe we decrement left and decrement right, and then an action happens. Let me make sure left is one indexed, which is kind of weird. They don't really mention it except for in the thing. So if left is 1 and we decrement it, then we want to operate on the current node already. Okay, so that's good. So then if left is oops, oh, the other way around, whoops. Yeah. No, we want if left is, if this is true, then we want to do some swap, assuming that right is also, if right is greater than or greater than 0, something like this. We might have to kind of muck around with it a little bit. But yeah, so here now we want to start swapping if this is true. So then now we have, and with linked list problems, as I always say, it's also helpful to have a notebook or something drawing so that you can kind of visualize your pointers, because at least for me, it's very easy to mess up. But okay, so then now we want, so next node is equal to current.next, so that we can kind of, let's actually just put this here. So then no matter what we do, we can propagate maybe. I don't know if that's true. We'll see. And then here, we want to make current.next we want to set it to current, right? Because now we want to reverse the pointer. This is very awkward the way I'm doing it now, to be honest. I think maybe I'll just do something. Instead of doing it in these things, I'll just kind of do it this way. And then just put it in a different loop. So then I don't have to worry about... Oh. Right. Is that true? I think technically we want to do it before we move to the next, so I think that this is better. Okay. And then now we're between left and right, right? So while current that next is, oh, it's not none also. Huh. Man, I'm very silly today. And right is greater than 0, maybe greater than equal to. I have to kind of double check later. Okay, so now in this case, but I think one thing that I was trying to do, if you are struggling with them, is that I saw that my loop invariant was kind of getting too confusing for the first loop, so I broke it into 2 loops, and probably will have a third one later, but at least 2 loops, so that so that the loop invariant for that loop is very easy to kind of hold variant, right? Like for this one, we just want to make sure that at the end of this loop, left is equal to 0 or less than 0, I suppose. Well, no, it has to be equal to 0 because you can't really leapfrog and it starts at 1. Yeah, and then now that means that the last node is going to be this node, but that's fine. Okay. So yeah, so then now we want next node is equal to current.next. These ones I always struggle with. Right, we want to set something like current.next.next is equal to current. But I think we have to, it's a little bit tricky because this is the last node. So we actually want it to like be none. But maybe we'll worry about that later. Yeah, maybe I say set something like last node is equal to current, because this is going to be the last node, so anything pointing to it, we'll have to set it to none later. It's not a very clean way for sure. I think this is fine in concept, but the reason why I'm hesitating a little bit is because this is not sufficient. Because then now next node is current.next, so I think we have to. I have to do this instead because that's the one that we lost reference to. Right. Maybe instead of using current.next, I think what I have to do is just next node is equal to current.next, and then just keep on doing it every or next node is equal to next node. Next node is equal to current dot next. So that we kind of like move them in lockstep, because otherwise this may be a little bit tricky, I think. Current dot next, or in this case we can just use next node is equal to current, and then current is equal to current dot next. But then I don't even, this part isn't even that true anymore, right? So I think it's just equal to next node. And then now, oh, and also decrement. That doesn't really matter where that is. And then now right is going to be 0, and then we want the first, maybe last node is current dot next. Maybe that's a little bit clearer, because then now we want to set last node is equal to, now it's equal to current dot next, and we're done. Maybe. Oh yeah, this is psycho. That's odd, but maybe not. I don't know. Okay, that's why that's true. Probably did something wrong. I mean, obviously. So next node. Well, I definitely have done it wrong, because I think I have to last node is this. Oh, this is just weird. What am I doing? Last node dot next is equal to current dot next is what I meant to do. But I mean, it still may be wrong. Still should be wrong, in fact. But so this is because basically now we're connecting the pieces back together, and the last node. Yeah, so then we want that node to point that. I think this part is right, but we also need the current previous, maybe this is how to say this. Maybe this is last node of the chunk, and then the first node is going to be equal to current, I think, and then so I think first node is equal to the current dot next, and then oh no, first node is dot next equal to current, and then last node dot next is equal to current dot next. Something like this, but I feel like I'm pretty sure this is wrong. But let's take a look. Yeah, I have to print this out in a good way. So I think it's impossible to debug if you don't at least print it out. So let's just print out the first 20. Sentinel. And I know that starts off with -1, but I don't see it. Okay, so it goes 1, 3, 2. I mean, this is already wrong, but so easy to get wrong. Wonder if I did it better last time. Today, I'm gonna blame the heat. Okay. So the 2 points at the 2. Why? Alright. Let's take away these 2 things first. I think this, I mean, my risk is about this chunk, I think, but yeah, hang on, what is going on? 1, 2, 1, 2. Looks like it's fine. I actually don't know how this gets to. Do I print it twice? How do you get the -1 and then 5? I mean, how does that happen? Like it's an infinite loop, but then it does, and then at some point it loops out. How? That's actually nuts, isn't it? How does it go into this and then loops out? Huh? That is that wild? Actually, I don't know how this happens. How does it like? It's either infinite loop or it doesn't. I don't know how it goes back to -1. Man, this life is wild. Okay, all right. I mean, this is fine because it loops out, right? This is just saying that it goes to the end and then it's none because we don't manipulate anything. But if this is a cycle, how does it have both have a cycle and this at the same time? That is wild, huh? All right. I think it's time I think about what I'm doing. So current.next. Let's say we're already at the beginning. Next is equal to, okay, so so we look at this node and we look at the next node, right? Okay, and then oh, I think I see. This is not right, is it? Next node.next is 0 current. Let's see. No, that part is right. Let's just do one iteration and then see what happens. I still don't get this debug of how do you just loop out so quickly? Like, how does this happen? There's some weird thing with Leetcode happening, to be honest, I think. Because how do you, like, okay, this ends and then this, and then it prints. I don't, or is that, oh, I see. This is the second test case. I see. Okay. It's very confusing the way they print it out. I see. That's the second test case. Okay, fine. Okay, now I get it. So after one loop, what does it look like? Oh no, it looks the same. Okay, so then current is equal to next node. All right. I think I am just going to follow my advice and draw some notepad. Or maybe I just kind of... I think this is also where a debugger would help because you just kind of trace through it. Usually I don't need it, but I forgot that I have this thing. So let's take a look. All right. So current is the beginning node. First node is the current. Okay, head. I actually rarely use this because I don't know. You don't. With other stuff, there are other ways to do it, but with linked list, it's a little bit tricky. Okay. So next node is equal to 2. Okay, that makes sense. Next node dot next is equal to current. Okay, I mean there's a cycle, but that's for good reason. Yeah. Okay, this is useless. This is useless because this doesn't print anything useful. I need... okay, maybe I can redo it. Hang on. What I want is next node.value and then next node.value. So I don't need to see the entire tree, which is the issue. Okay. Okay, so next node is 3. Can I drag and drop? It's in the weird order. Okay, fine. And then current is 2. Okay. Okay, right. So current down to the next node. Okay, so then now you have the 2 and the 3. Next node dot value is 2. I think something is off here. I think this is next node next node dot next. Okay, fine. Maybe that's a good beginning. We'll see. All right. 1, 3, 2. Also, I think I'm off by 1. That's why I'm getting 1, 3, 2 instead of 1, 4, 3, 2. I mean, if this is an infinite loop, then yeah. Okay, so this is an infinite loop, but that means that we didn't. It goes from 2 to 3. So that means. Where do I have the last node? Last node's a little bit weird. That's why. No, so the last node is your current dot next. So this is, I think first dot node is your current is right, but the current dot next is wrong. Because current is not the current anymore. It should be like next node is what I mean. Maybe. We could debug this again to make sure that the first node and the last node is the same, or is what we expect rather. Alright, so first node dot value. Okay, last node dot value. It's 2, yeah, okay. So then now we want the thing that is 2, we point next node, and next node should be 5, but instead we have 4. So that's why this is wrong. So next node, next node. It's very easy to confuse what I want. Let's try again. 1, 4, 3, 2, 5. I guess now that we're good. Okay. As you can see, very easy to mess up, and you have to make sure all your pointers are and naming things is right. I think I confused next node and next node in a couple of places. That bit me a little bit. Let's test a little bit more. 1, 5, 3, 5, and I guess just 1, 3 or something. Okay, so that looks good. That makes me feel okay to submit. Definitely feel sloppier today than usual, even though it's apparently my 4th time. Once a year. A linked list a year keeps the linked list doctor away. At least I got it right, I suppose. How did I do it last time? This is just... I mean, it is tighter, but I think I used better variable names that time. Well, this time it's just using deck, which is lazy. And then that time I'm using stack, which is also lazy. Maybe. I don't know. It uses way more additional space as well. Anyway, this is linear time, constant extra space. So yeah, that's all I have for this one. It took a while. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.